Good evening and welcome to tonight's webinar for CIS 205 T&I. Tonight we will be discussing CompTIA's Network Plus exam, which is number N10-005, and tonight we'll be covering objectives 1.1 and 1.2 of the exam. So now you're wondering, what are those objectives? Well, 1.1 is comparing the layers of the OSI and TCP/IP models. So we will first discuss the OSI model, and then we'll discuss the TCP/IP model. Objective 1.2 is classifying how applications, devices, and protocols and other things relate to the OSI model. So let's go ahead and begin with objective 1.1. So the first thing I'll say is that in the early days of networking, there was no model, no OSI model. If you had an IBM machine, you could only network with another IBM machine. If you had a DEC, guess what? You are stuck only being able to talk to a DEC because nobody was concerned about compatibility. Well, then along came the ISO, and they like to make things standard, so they developed the OSI model. The OSI model is broken up into 7 different layers, layers 1 through 7. Usually when you see it written out and represented, it goes top to bottom, layer 7 down to layer 1. And the reason for that is the way they work. Layer 7 is actually what does all the initiating and passes it down to 6, down to 5, down to 4, down to 3, down to 2, down to 1, out the wire and over to the other side. So layer 7 is application. That's basically who's asking to communicate. Layer 6 is the presentation layer, and that is the layer on which the language that's going to be used is determined. There's several different ones that can be used. The presentation layer is the one who determines which one it's going to be. That's also where most encryption begins. It doesn't have to be at the presentation layer, but that's where it begins, usually. Layer 5 is the session layer, and it is responsible for setting up the communication channel and for tearing it down. Layer 4 is the transport layer. You're going to have to learn a lot about layer 4. That is where TCP resides. And you have 2 basic styles of connection. You have reliable connection, and you have unreliable connection. It just is determined by what you're doing, by which one you get. Layer 3 is the network layer. And the network layer is logical addressing. And that's basically, where are you? Layer 2 is the data link. That's actually made up of 2 sub-layers. One is the MAC, and one is the LLC. And that's basically who you are and what is your address. Layer 1 is the physical. And that is basically has to deal with signaling methods and how it gets from one point to the other. One of the things to keep in mind is that the OSI model is a reference only, and everybody implements it in a slightly different manner. Cisco implements it a little bit different than Microsoft. Microsoft implements it different from Apple. But they all interoperate because they all adhere to the standards, to the reference. Now, here's a little bit more detail about the layers. Layer 7, the application layer. This is what requests the network resources. Don't confuse it with a program. It can be a program, but it doesn't necessarily have to be. A great example is Internet Explorer is a program that uses HTTP at the application layer to request and receive a web page. FTP TFTP, SMTP, POP3, DNS, DHCP, all of those function at the application layer. There's a whole bunch more. You can actually look it up on Wikipedia if you want to get even more into detail. Layer 6, already mentioned, that's the presentation layer. That's responsible for taking code from a program or application and converting it into a format that the other end can accept. And when the receiving layer 6 receives it, it converts it into a format that its layer 7 can handle. One of the great examples is taking an EBCDIC file from the layer 7 and breaking it down into an ASCII for transmission, and then reversing it at the other end, making it an ASCII response into an EBCDIC file for the layer 7. Even if both layer 7 applications speak the same language, the presentation layer is still involved. I already told you that layer 5 is responsible for setting up and tearing down the communications channels. It basically says when and where the communication is going to take place. So layer 7, which is responsible for delivery of network communications. Like I said, it can be reliable, which is TCP, with error detection and packet ordering, or it can be unreliable, which is UDP, which uses best effort delivery only. So now you're kind of wondering why you might want to use UDP. Well, because it has lower overhead. It's a little bit faster. It's mostly used in applications where it's more important to have the speed than to worry about a lost packet. A good one is voice over IP. If you had to wait for the error correction and everything else that TCP involves, communication would be really choppy. So UDP is used in most voice over IP applications. So then we go down to the network layer. Network is the logical addressing, and it is responsible for communication between networks and networks only. It really does not care who the final destination is, only what network they reside on. You can kind of think of it as the city, state, and zip code portion of a physical address, which you have in the mail. The data link layer, that's the layer that is responsible for knowing the final destination. You can kind of think of it as the house number portion of a street address. It is broken up into the two layers, the LLC, which is link layer control, and the MAC. Couple of examples of layer 2 protocols are Ethernet, which everybody should be familiar with, and point-to-point protocol, which you will get into later in this course, at least you should. And then we break it down into the physical layer. That's the one that's responsible for taking the frames from layer 2 and breaking it into bits. And that's the signal that goes down the wire. There's also hardware that works at the layer 1, and the best one example of that is a hub. A hub is a layer 1 device. A switch, in contrast, is a layer 2 device, and I will talk about that a little bit more later. So now we move to the TCP/IP model. So again, a history lesson. Everybody uses TCP/IP nowadays. It used to be there were a whole bunch of different networking standards that you could use, you could create networks out of. Nobody uses them really anymore, except in very, very legacy type operations. Everybody uses TCP/IP. So that means that it had to have its own model so that everything can communicate. TCP/IP is a little bit more A little bit easier to get your mind around. It's only broken into 4 layers: the application layer, the transport layer, the internet layer, and the network interface layer, which is also sometimes called the link layer. As with the OSI model, the TCP/I model is reference only. Different vendors, again, break it out into different ways. So now let's kind of compare the two. In the TCP/IP model, the application layer is responsible for layers 5 through 7 of the OSI model, which means it's got session, it's got presentation, it's got application, and that's what it does. It takes those top 3 layers of the OSI model and rolls it into one layer. The transport layer of the TCP/IP model, maps directly to the transport layer of the OSI model. And again, that's TCP and UDP. And the network layer, again, maps directly to layer 3 of the OSI model, and that's IP, and that's a networking address. Now the TCP/IP model takes the last 2, which is the data link and physical, and rolls it into one called the network interface layer. And the reason they do that, well, that's because sometimes it's hard to break out those 2. But when you're having a problem, most technicians go back to the OSI model because it breaks things out a little bit farther and it's a little bit easier to deal with. As far as being a network technician, I've never tried to explain something to somebody using the TCP/IP model. I always end up going back to the OSI model because it's a little bit easier for most laymen to understand. And it's easier to pinpoint issues. When you're looking for a physical issue, you look at the physical layer. So now let's move on to objective 1.2. And then here, unfortunately, you're going to have to memorize a whole bunch of things. Sorry, that's just the way of it. The first thing that you need to know, MAC addresses. MAC stands for Media Access Control, and if somebody's talking a MAC address, that maps to layer 2 of the OSI model. It is a permanent 48-bit hexadecimal number. It's usually burned right into your network interface card or to your router or whatever else has a MAC address. Everything does have a MAC address, by the way. The first 24 bits of the 48 are your OUI, your organizational unique identifier. The second 24 bit are usually assigned by the manufacturer, and a lot of the times they just use the serial number and make it a 24-bit number and stick their OUI on the front, and there, voila, you have your MAC. And it does represent the physical address of the node. You know, you can only have, it has to be unique on the network on which it resides. In most cases, that's not a problem. 24 bits is actually a fairly large number. Your chances of having 2 network interface cards by the same manufacturer having the same last 24 bits is kind of slim. So usually that's not a problem. Now your network switch, which is a layer 2 device, uses the MAC address that is in the frame that it receives to determine which port it sends that frame out. Another name for the MAC address is the UEI-48. Now guess what? The IEEE decided that 48 bits wasn't quite enough, so now you need to know that there is an EUI-64 that is coming out. It is the replacement for the standard 48-bit MAC address. IP addresses. IP addresses always map to layer 3, and those are Internet Protocol addresses. They are logical in nature. just about anything you can assign an IP address as long as you follow the proper addressing schemes. I'll get to that here in just a moment. But you get to assign it, or your equipment does. IPv4, which is what everybody's most knowledgeable about, is a 32-bit address, and it is dotted decimal. Those are ones like 192.168.1.0. That is an IPv4 address, and it's 32 bits long. And you will have to learn some binary in this course. Sorry, but you're going to need to know it, especially if you move on beyond the Network Plus exam. IPv6, well, that's a bit bigger. It's 128-bit, and it is denoted by hexadecimal, and it uses not semicolons, it uses colons. It is huge. For IPv4, there are essentially a little over 4 billion individual IP addresses available. IPv6, it is quintillion. There's enough address space in IPv6 that everybody and everything could have its own IPv6 address. The transition is occurring, but it's being very slow. I do believe we actually ran out of IPv4 addresses last year, but everybody's still using IPv4 because it is what everybody is familiar with. A couple of years down the road, everybody will be familiar with IPv6. So cables, when you're talking cables, those are layer 1. Hubs are a layer 1 device. The reason they're layer 1 is they don't care anything about addressing. It receives a signal on a port, and it repeats that signal out every port that it has. Now, layer 2, which is a switch, or switch is a layer 2 device. It knows the MAC addresses. It's a whole lot smarter than a hub. It's a whole lot faster. You will get to know switches intimately. And when it receives a signal on a port, it looks at the destination MAC address. It checks its MAC address table, and it will only send that signal out the port where it knows that MAC address will receive it. Bridges are a layer 2 device. They know MACs. They don't know network addresses. A bridge is fairly uncommon anymore, but you can still find them. One of the interesting things about a bridge is it can change network media types. It can connect to a coax network and change that signal to a Cat5 signal and send it on to another segment. It can also filter traffic by segments. A multi-layer switch is kind of a hybrid. It resides on both layers 2 and 3. Most of its functions occur on layer 2, but it does know network addresses, so it does have some layer 3 routing capabilities. Routers are the main device that live on layer 3. They're only concerned about IP addresses. They don't care about MAC addresses. They don't care about anything but IP addresses, network addresses. Just like a bridge, they can and often do change the network media topology. The most common one is taking input from Ethernet and sending it out on a serial line over the telephone wires. Encryption devices. Okay, this one's kind of tricky. The layer they reside on depends upon the protocol that's in use. SSL and TLS, which everybody should be familiar with, especially when you're on the internet, that resides at the presentation layer, layer 6. When you see the little lock on your web page that signals you're on a secure site, that's either using SSL or TLS. By the way, TLS is Transport Layer Security. But if you are doing some networking, boy, now the term escapes me and I feel kind of silly, but if you're calling in from your home office to your work office and you've now got that virtual network that usually uses point-to-point tunneling protocol, which will encrypt your traffic, well, that resides at layer 2. Now let's talk about common networking terms that you're going to hear. When somebody says that the transport layer handled a segment, that means that it received a data stream from the upper layers and it broke it out into a segment. It put a header and a trailer on it, but it's a segment at layer 4. Layer 4 then sends it down to layer 3. Layer 3 receives the segment and it breaks it into packets and adds IP addressing. Also adds a header and a trailer, and then passes it down to layer 2. Layer 2 receives the packet, breaks it into a frame, adds the MAC address of the source, and sends it on its way. It also adds a header and a trailer. And it hands it down to the layer 1. Layer 1 breaks that frame into bits, zeros and ones, and sends it over the wire. It's important that you know the order that they go in. The way that I did it is I just remembered segment packets frames, and I went S was higher in the alphabet, it's higher in the layer. And B is the lowest layer, and it's the first one in the alphabet. And then you just kind of work that way. You are going to need to know that. And actually, that concludes objectives 1.1 and 1.2.